Buongiorno, vi ringraziamo per esservi iscritti al webinar di oggi. Vi ricordo che il webinar è registrato, tutti i partecipanti non hanno il microfono acceso. In caso di necessità potete alzare la mano e il moderatore vi contatterà privatamente. Vi invitiamo a scrivere eventuali domande di approfondimento nella casella in basso a destra sui vostri schermi. Risponderemo dopo l'ultima presentazione. Iscrivetevi alla newsletter sul nostro sito www.kistler.com per rimanere aggiornati sui nostri prodotti ed eventi. Good morning. Thank you for joining our webinar. I remind you that the webinar is recording. All attendees are muted. In case of questions, please raise your hand and the moderator will contact you privately. If you have any question regarding the topic of today's webinar, please write them in the Q&A box on the bottom right side of your screen. We will answer you at the end of the last presentation. Please do not hesitate to subscribe to our newsletter on our website www.kistler.com to remain updated on our products and our event. Grazie a tutti per esservi connessi. Passo la parola all'ingegner Marazza, Area Sales Engineer e South Europe Plastic Manager Application di Kistler Italia, che vi presenterà l'argomento e i moderatori di oggi.
Bene, Valentina, innanzitutto ti chiedo una conferma che si senta la mia voce.
Sì, si sente.
Perfetto, grazie. Bene, possiamo iniziare il webinar, siete tanti iscritti. Buongiorno a tutti, io sono Roberto Marazza, Sales Engineer di Kistler Italia. Vi ringrazio tantissimo per l'interesse e la partecipazione a questo webinar. Oggi, insieme ai colleghi della casa madre, che ringrazio per il loro supporto e il loro contributo, vi presenteremo le soluzioni Kistler legate al miglioramento dei processi di avvitatura. Di seguito vedete l'agenda del webinar. Inizierò presentandovi il gruppo Kistler, per chi ancora non lo conosce, e vi presenterò le business unit, oltre quella legata all'avvitatura, in cui è suddiviso il gruppo Kistler. Dopodiché vi fornirò una panoramica delle applicazioni e dei prodotti legati al mondo dell'avvitatura. Queste applicazioni saranno poi approfondite dalle presentazioni dei colleghi della casa madre, in particolare per quanto riguarda il calcolo dei coefficienti di attrito, il test dei tool di avvitatura e i sistemi per il controllo qualità del processo. Alla fine avremo tempo per le vostre domande e le conclusioni. Iniziamo dalla presentazione del gruppo Kistler. Kistler è una multinazionale svizzera fondata nel 1959, quindi con ben oltre 60 anni di esperienza nella produzione di soluzioni legate alla misura di forza, coppia, pressione, accelerazione. Attualmente siamo circa 2200 dipendenti, dislocati in oltre 60 sedi nel mondo e seguiamo più di 10.000 clienti attivi nel mondo. Abbiamo oltre 700 brevetti registrati e collaboriamo con più di 30 università e centri di ricerca nel mondo. Il mondo Kistler è suddiviso in diverse business unit che vanno a supportare i nostri clienti nel mondo. Abbiamo business unit legate principalmente a quello che è il mondo della ricerca, dei test in ambito automotive, quindi business unit per lo sviluppo dei motori, ad esempio, la sicurezza e la durability, la dinamica dei veicoli. Abbiamo poi business unit legate all'industria di processo, quindi lo stampaggio di componenti in plastica, stampaggio a iniezione, applicazioni legate al mondo delle presse elettriche e all'assemblaggio, alla formatura di componenti. Poi abbiamo soluzioni per il test della caratterizzazione dei motori elettrici. Possiamo fornire anche soluzioni customizzate a livello industriale per i nostri clienti, mondo dell'avvitatura che tratteremo oggi e soluzioni in ambito smistamento e selezione dei prodotti tramite sistemi di visione. Abbiamo poi altre business unit più trasversali che sono legate al mondo della pesatura dinamica dei mezzi in movimento, quindi in campo stradale o in campo ferroviario, soluzioni in ambito biomeccanica, misura delle forze durante le lavorazioni per asportazione di truciolo, balistica, test e misura in generale in laboratorio, termoacustica, tecnologia in ambito ferroviario e controllo della velocità. Oggi ci concentreremo come tema per la business unit Fastening Technology, Avvitatura, che è nata fondamentalmente da un'acquisizione di più di 5 anni fa del gruppo Kistler dell'azienda tedesca Schatz, anch'essa con oltre 60 anni di esperienza in ambito avvitatura. La business unit Fastening Technology principalmente desidera offrire tecnologia ed esperienza per assicurare ai clienti la qualità nei processi di avvitatura e anche assemblaggio ad essa connessi. Quindi gli obiettivi sono quelli di incrementare la qualità dei prodotti e dei processi, ovviamente puntando anche a una riduzione dei costi intrinseci, assicurare conformità agli standard a livello internazionale definiti dalle aziende, incrementare la sicurezza di processo, prevenire reclami di responsabilità sul prodotto e documentare i risultati in modo sicuro e preciso. I nostri principali mercati sono l'automotive, l'aerospace, ovviamente i produttori di viti, dadi, componenti filettati, ma anche l'industria più in generale, che inizia ad avere richieste sempre più stringenti e importanti dal punto di vista qualità. I nostri prodotti, le nostre applicazioni, la nostra esperienza, fondamentalmente possiamo suddividerla in 3 ambiti legati a componenti, strumenti, processi. Quindi il primo ambito, che sarà quello che approfondiremo per primo, è legato alla determinazione delle caratteristiche meccaniche dei componenti, quindi viti, dadi, parti con filetto in generale. Il secondo ambito è legato ai sistemi di verifica degli strumenti di avvitatura e il terzo ambito è legato all'assicurazione qualità nei processi di avvitatura. Tutte queste applicazioni hanno in comune una cosa, un fine, che è quella della sicurezza, responsabilità del prodotto e dei processi ad esso collegati. Come dicevamo, il primo ambito quindi si rivolge ai componenti. Di seguito vedete alcuni esempi di quelli che sono i componenti che possiamo andare a testare con i nostri sistemi, quindi viti e dadi con dimensioni da M3 a M72, viti e dadi con elementi di bloccaggio e poi altre parti con filetto, ad esempio anche viti legno. Per questa soluzione proponiamo dei sistemi che vanno a definire quello che è il calcolo dei coefficienti di attrito. Ora lascerei spazio a un brevissimo video che vi presenta il nostro sistema di punta, Analyze System. È un banco completo in cui vedrete la parte attuativa, i trasduttori per la misura di coppia, angolo, forza, l'elettronica di gestione del banco e il software di programmazione, analisi, archiviazione dei dati e definizione delle procedure del test. Non parlo sopra il video in modo tale che spero sia di buona qualità. Bene, avete visto velocemente il funzionamento di questo banco, poi entreremo nell'approfondimento, nella presentazione successiva. Pardon. Avete visto quindi quello che è il sistema che noi chiamiamo Analyze System per le viti. Insieme adesso possiamo offrire un'altra tipologia di banco che permette di fare quello che viene chiamato in gergo Juncker test, quindi un test andando a sollecitare trasversalmente il componente sotto test, quindi mettendo in vibrazione e andando a vedere quello che sarà il rilascio del sistema di fissaggio che abbiamo sotto test. Abbiamo poi soluzioni speciali legate all'industria aerospaziale, oppure soluzioni per test in camera climatica o soluzioni speciali come ad esempio andare a monitorare coppie fino a 500.000 Nm, oppure soluzioni anche con manipolatori in cui andiamo a replicare quella che sarà la condizione reale di avvitatura. Il secondo ambito invece è rivolto agli strumenti, quindi proponiamo delle soluzioni di verifica degli strumenti per avvitatura, quindi verifica di strumenti per la misura solo coppia o coppia-angolo. Nell'immagine vedete alcuni esempi di questi strumenti, quali ad esempio chiavi dinamometriche e avvitatori. Anche in questo caso vi farei vedere un video di un nostro sistema che si chiama Combi Test. In realtà il video è diviso in due. La prima parte, sempre di questo sistema, è legata alla taratura delle chiavi dinamometriche. La seconda parte, sempre con il sistema Combi Test, è legata al collaudo degli avvitatori. Inizio con la prima parte, quindi legata alle chiavi dinamometriche. Bene, questa è la prima parte delle chiavi dinamometriche, la seconda parte è legata invece all'avvitatura, quindi vedrete la simulazione di un simulatore giunto meccanico con il quale viene collaudato l'avvitatore. Ecco, di questa tipologia di strumenti di verifica abbiamo diverse opzioni. La prima opzione è quello che chiamiamo CerTest W, è un banco di collaudo per chiavi dinamometriche coppia angolo. La seconda possibilità è il banco che chiamiamo CaliTest per andare a fare il collaudo e la taratura di chiavi dinamometriche. Abbiamo poi l'ultima tipologia che si chiamano CerTest o CombiTest come banchi di collaudo avvitatori e taratura di chiavi dinamometriche. Considerate che di queste soluzioni abbiamo sia la posizione, diciamo, la postazione fissa, sia la postazione mobile trasportabile, eventualmente con batteria, quindi posso spostare il sistema di verifica all'interno della mia fabbrica, del mio reparto produttivo. L'ultimo ambito è legato invece all'assicurazione qualità dei processi di avvitatura, quindi con dei test a campione, dei test di distacco, con strumentazione che permette durante il processo di andare a verificare quelle che sono le caratteristiche più tipiche del processo di avvitatura, quindi con la definizione di grafici coppia tempo, piuttosto che coppia-angolo, e la possibilità ovviamente di tenere traccia del test che è stato fatto. In questo caso utilizziamo un sistema di controllo, lo vedete nell'immagine al centro, che si chiama Inspect Pro. È un pannellino di medie dimensioni, potete vedere nelle immagini a destra. È un controller che è possibile utilizzarlo sia come postazione fissa sia come postazione mobile, quindi trasportabile. Nell'immagine in basso a destra vedete che l'operatore lo porta a tracolla, in quanto il pannello è disponibile anche con batteria. A questo controller possiamo collegare diverse tipologie di trasduttori, da trasduttori per la misura di coppia rotante piuttosto che coppia fissa, chiavi dinamometriche o trasduttori anche di forza. All'interno di questo controller è possibile inserire opzionalmente diversi settaggi software a seconda del processo e della tipologia di test che dovrò effettuare. Il tutto è poi remotabile, quindi con anche la possibilità di esportare dati per tenere la tracciabilità completa del processo produttivo e di test. Come ultimo video vorremmo presentarvi anche la possibilità di associare quello che è un processo, un controllo di un processo di assemblaggio, quindi con cella di carico per la misura di forza, a quello che è un processo di avvitatura, quindi con controller collegato a un trasduttore di coppia. Nel video che vi mostrerò vedrete un controller che si chiama Maximus BL in questo caso, a cui colleghiamo una cella di carico. Alla seconda postazione, successiva alla prima, ci sarà lo stesso controller collegato a un trasduttore di coppia, un torsiometro. Dalla prima postazione faremo un controllo di inserzione di un componente su un pezzo. Se l'esecuzione sarà giudicata positiva tramite delle finestre di controllo posizionate nel controller, a questo punto il pezzo potrà passare alla seconda postazione e fare a questo punto una verifica di avvitatura di un componente sullo stesso pezzo. E successivamente ci sarà anche in questo caso la valutazione pezzo buono, pezzo scarto. Se nella prima postazione il componente sarà giudicato non buono, non andrò alla seconda postazione, quindi eviterò di proseguire nella catena produttiva e il pezzo potrà essere immediatamente scartato. Faccio vedere il video. Bene, considerate che come Kistler abbiamo un'ampia gamma di celle di carico e di tipologie di controller per il controllo forza-spostamento, forza-tempo, coppia-tempo, coppia-angolo. Come avete potuto intuire, le nostre soluzioni non si fermano quindi solo all'avvitatura, ma possiamo andare a proporre soluzioni per diverse tipologie di processi industriali. Vedete qualche esempio indicato nella slide come operazioni di clinciatura, imbutitura, funzionatura, saldatori a punti, prove di rottura, inserimento, assemblaggio di componenti, presse manuali come nel video che avete appena visto, oppure anche presse elettromeccaniche. Vi invitiamo quindi a questo punto a contattarci qualora abbiate all'interno delle vostre aziende anche queste tipologie di applicazioni. Non da ultimo ci teniamo a precisare il service che possiamo mettere a disposizione dei nostri clienti in tutto il mondo. Come service intendiamo ovviamente attività di consulenza in primis, training e assistenza all'installazione, commissioning durante le prime fasi di utilizzo delle nostre soluzioni, ma anche supporto da remoto, test e non da ultimo anche la manutenzione ordinaria o preventiva, quindi riferita alle calibrazioni annuali che vengono suggerite ai clienti o che sono, diciamo, necessarie, ma anche scorte, ricambi, servizi in emergenza. Quindi cerchiamo di assistere i clienti al 100%, non solo con i prodotti, ma anche con tutto quello che è il valore aggiunto nato dalla nostra esperienza. Concludo invitandovi a valutare quelli che sono i vantaggi indiscussi di quello che è il non trascurare la verifica dei componenti, degli strumenti e dei processi. In questo caso, quello che sicuramente possiamo affidarvi e su cui possiamo supportarvi è ottenere una maggior qualità di quella che è la vostra produzione, garantire la tracciabilità di tutto il processo produttivo, ovviamente andando anche a permettervi di ottenere delle prove nella ricerca di eventuali responsabilità dovute alla produzione. E il tutto si conclude ovviamente con l'ottenimento e il mantenimento di clienti soddisfatti. Io vi ringrazio intanto per avermi seguito in questa introduzione. Vi invito eventualmente a segnalarci anche quali possono essere i vostri temi di maggiore interesse anche per future evoluzioni dei nostri webinar. Adesso passo la parola al collega Christoph Bodesteiner, nostro product manager da più di 15 anni in Kistler, in modo tale che possa approfondire il primo tema legato al calcolo dei coefficienti di attrito.
Okay, so I hope you can hear me.
Yes.
Yes.
Okay, great. Thank you very much for the short introduction to Roberto. Thank you very much to Valentina for organizing the whole event. My name is Christoph Bodensteiner. I'm a product manager fastening technology in Kistler Remscheid. And yes, this things I make since about 15 years. So I want to talk about our applications a little bit. So Roberto already told you that we have different applications in the area of process control, the area of bolt testing, and in the area of bolted joints. And this is the area I want to talk now a little bit. And before we start with the products, yeah, I want to give a short basic introduction. So we all know the bolt. We know that the target of the bolted joint is the connection of two or more parts together. So they will work like one part if we put external loads on it. So the design is that we need to create a clamping force during the fastening, and this force withstand the external forces then. The big advantage of this fastening method or of this joining element, let's say in this way, is then this connection method is a detachable method and a method where we can make a process capability verification. So how to create this clamping force? normally there is only one way to make it in an easy way. It's by using a torque wrench or, for example, a nut runner, and create the torque which creates then the clamping force. And when we take a look how much force we need to create, then we have to take a look that we reach a minimum required clamping force. Otherwise, the connection will fail because the components will loosen. Or, and this is the second point, we have to take care to not exceed the maximum clamping force of the components. Otherwise, the parts will be damaged and the connection will also fail. So the influence parameters on this clamping force we create as a target parameter is not only the torque. So if we take a look on the informations we will find in the VDI VDE 2645 sheet 3 standard, you will see that there are influences based on friction, based on setting effects, based on component faults, based on the complete design, the production, and the power tool. So there are a lot of influences, and this will take hours or days to explain all these points. So I'm reducing the whole thing today to the friction. And the friction is a very important part because a huge part of the applied energy during the fastening will be converted into bearing and thread friction and will not create the clamping force. So when we have variations in the fastening torque and the friction coefficients, we get big variations in the clamping force. When we make a standard fastening, our target is normally an area of about 90% proof load, 90% of the load on the bolt based on the yield point area, so not to overload. And when we make such a fastening to this 90%, we create, in this case, for example, about 42.6 Newton meter to create the 30 kilonewton, which are the 90% for this bolt. And when we can do it in this way, just to apply the torque and reach the clamping force, then it would be very easy. But unfortunately, as I told before, we have influences, and the influences are, for example, the variation in the fastening tool. So the fastening tool do not create always exactly 42 Newton meters. So we also have in the tool variations. So we have the variations in this area of the tool, and additionally, we have variation in the friction coefficient up to the coating. Every coating is not exactly the same. So for example, when we have a variation between 0.1 and 0.2 in the friction coefficient, then you see that the window will be opened to a very wide range. So we do not reach our target, as I showed before, with the 30 kilonewton. Due to these variations, we get a clamping force in the area between about 15.7 and 31.8 kilonewton. So we have a really big spread of about 16 kilonewton. And if you take a look in the graph, that's a thing which you should think about. You get here a clamping force in the area which can lead to the fault when all these tolerances are too big. This is the reason why we have to test the bolt as a tool on one side, where Carsten will talk about a little bit later. And on the other side, we have to take a look for the friction coefficient. To make a test for the friction coefficient, we need a system consisting of mechanical parts, sensors, a measuring unit, a controller for a motor to make the fastening, the motor itself, the mechanical unit, and of course, a PC with the software to make the evaluations. When we take a look for the mechanical units, then you can see there are different possibilities. One possibility is a vertical system, which is used normally in the area of very small bolts, of bolts for wood fastenings, and so on. Then we have a big area in the horizontal systems. So on the left side, you see a system up to 500 Newton meters, so it's an area of about M16. And on the right side, you see a little bit bigger system, which covers the area of about M72. So this is the area of the windmill industry, for example, with very special requirements. And so you can see we have all possibilities for different ranges. Another part are our actuating systems. So if you want to make, for example, tests directly on a part, on a motor, on an engine, on some parts in the car, we have the actuating systems up to 1000 Newton meter to make the fastening test directly there. Not only the friction coefficient is an interesting thing, also the loosening behavior of locking parts. There we have vibration systems, so-called UNCAS systems, where you apply a defined vibration on a locked part and take a look if it's working or not. And the systems are normally combined with our friction test systems to make a complete evaluation of these things. Yeah, you see, there are a lot of possibilities, but our systems are normally 100% customized because there are many, many different requests and different standards. And so, for example, we have systems where we make tests in a heating chamber with a temperature of up to 150 degrees Celsius. Or on the right side, you see a system for a special application with different motors, different sensors combined in one system. So this is a big advantage of Kistler. We have the possibility to customize really the systems based on, of course, standard components, but every system is based on the needs of our customers. The second big part bigger part I want to talk is software, because as I told, the requirements are different. Also, the standards are different. There are many ISO standards, customized standards, and so on. And so I want to give a very short overview about some possibilities, just to give you an impression what are the different requests. So let's say the mother of the standards is ISO 16047. Which defines a standardized test to ensure that you can make a test for friction coefficient with reference parts all over the world and get always the same results to compare. So the test will be done normally that you make a fastening to 75% of proof load and take a look for the friction in the bearing surface between the bolt and the reference washer. Take a look for the thread friction between a reference nut and the the bolt, the thread, and of course the total friction coefficient out of the torque you apply in the clamping force. There are many influences in the friction coefficient, and this need to be checked. And you can see on the right side the graphs for the friction coefficient to know in which area you are. Based on this, we created a very easy possibility to enter these values, not looking always for the values in the tables and enter these tables in the fastening procedure. We have the possibility just to say, okay, I want to test the bolt size is M10, and I have a property class of 10.9. And the system calculates automatically the clamping force which is needed for the test. I just add the fastening speed and I press my start button and make the test. This is a big and good thing because it ensures that the customers make the test with as less influences from outside as possible. So the system take a look if the right sensor is connected, that the procedure of fastening and loosening is right, and so on, to reduce the failure possibilities. The ISO standard is one thing. There you are working with reference cards, but in reality you do not have plain surfaces and hardened steel. In reality, you have, for example, aluminium parts which you are fastening. You have welding nuts you are fastening inside. You have a cathodic coating on the surface. So this influences must be also taken in account. And for example, there is a test, the NBN 10544, which exactly take a look for these influences, and on the screen you can see at the moment, for example, this was a test on an E-coat, on a steel with some paint on it, and there is a special request that you make 5 tests, and on the 5 tests you make a 5 times repetition. Then the system take a look for the spread in the 5 tests and take a look if you are inside tolerance area or outside. The test procedure is very easy because it will be predefined during the installation, and a customer just need to change the bolt size, for example, and the target values. And all the other things will be done by the machine automatically. You just put the bolt inside, press the start button, and the machine makes the 5 repetitions of the fastening, and you get the graph and results. Very easy to this Daimler standard. We have the Volkswagen standard 01131, for example, working very close. There are not many differences. It's also a 5 times test. There is also a second part in this test where we take a look. We need to take a look for the loosening behavior, for the theoretical friction coefficient after fastening and applying a temperature on this part. Then we make a measurement if the part is heated up and take a look for a theoretical friction coefficient. A very popular standard is the Renault standard. It's basically the same like the Fiat standard. So there is a fastening to the yield point. The machine can automatically detect the yield point, or we enter the theoretical value out of the standard. And then there will be a calculation automatically in the range between 63 and 90%. And then the values will be evaluated. Another standard is the Scania standard, where you can see we make a fastening in the elastic area here. The red graph is the clamping force. And after this, this area, we go into the plastic area, and the bolt is getting longer and longer. And after that, we make the loosening just before the bolt will really break to ensure that we can loosen again without cutting out. And then there will be a lot of calculations at different areas in the graph for getting the results. The last thing I want to show is the test for the clamping behavior according to the ISO 2320 standard, which is made for bolts with for nuts with a locking element. So we have to make a 5 times up and down. Calculate also after the first on with applying a clamping force, the friction coefficients, and also in this case we just need to put the parts in the machine, press the button, and the machine makes a complete test with the 5 times up and down with delay times for cooling down the parts, for example, also. Okay, I have another one. It's EN 14399 for the windmill industry, for example, for bolts up to M39, where the standard defines that you need to fasten to define clamping force, and then you have to apply, based on the clamping length, a defined turning angle to ensure that the bolt withstand a fastening with some additional influences. So you can see we have a lot of possibilities in the software based on standards, on customer standards, but also according to the requests, the special requests, because we have a free programmable software where you can put the blocks together based on your needs. Yeah, thank you very much. This was my part. I think yeah, I'm in time. Just want to show with my last picture the area we are talking about, what we are doing. The big bolt is a M72. The small bolt is a M1.2, I think. So you can see a bolt test is not a bolt test, it's also up to the dimension. And yeah, would be great to talk with you perhaps a little bit later in the question and answer session. And I want to hand over to Roberto and Valentina again. Thank you for your attention.
Thank you very much for your presentation. I now authorize Carsten to present.
Thank you very much. Please.
Okay, we can see your presentation.
Can you hear me?
Yes, perfectly.
That's good. Sorry for that. At first, thank you for all the information at the moment. And now we would like to start. My name is Carsten Ziemke. I am the leader of the sales supporter here in Kistler Remscheid. And I'm working since 18 years in this company, and I'm the specialist in tool testing systems. And I would like to give you a small overview about the possibilities we have. And we start with a small agenda, and I would like to give you some basic informations about the tool testing, why we want to test the tools and how we want to do this. And I have some pictures also for the tool testing system and variations. And also, of course, like the analyze system, we also have here on part of the software. And at the end of all the sessions, we have a question and answer part. At first, you saw this picture by Christoph, and it is really necessary that you get a clamping force with using nut runners or tools with tightening torque, and the tightening process can be different. It could be, in this case, you see the tightening process as a hard joint. You see from the beginning of the situation that the head reach the material, it's on this position, and we only turn 40 degrees and reach the torque target we want to have. That means it is a hard joint. Another case, we have a soft joint. It is 180 degrees, for example. And in our systems, we have to simulate such different hardnesses. So we want to test the tools on our systems according to an ISO standard or according to the real joint characteristic where the tool is working. And therefore, we have to realize with different tool technologies. We have at first the nut runner. The nut runner is a continuous turning tool. It can be by air, it can be by an accu, it can controlled by a controller unit or whatever. And the second technology we realized is the pulse tool. And then on the other hand, we have wrenches, two different technologies of wrenches. One is a click wrench, another is a display wrench. And we have to manage these technologies. We have to simulate fastening points, and we have to calibrate the wrenches on an automatic system. We have guidelines, some ISO standards or mostly VDI standards. Maybe the famous ISO standard for testing nut runners is the ISO standard 5393. And additional to this, there are a lot of VDI standards, how to test the tools and how is the characteristic of the fastening points. This is written in the 2862. And for calibrate the wrenches, we have the ISO standard 6789. It's from 2017. It's part 1 and also part 2. Tool testing system and variations for nut runner and pulse tools. And for manual testing of wrenches, we have our product named CERTEST. It could be in a mobile or in a stationary system. The mobile system, you have the possibility to move in the production line and make the independent tests on this equipment of the tools which is working in this production line. The stationary system is mainly in the maintenance department for testing tools, not only on the parameter from the fastening point, also for the complete range of the tool, where you can decide is the tool maybe better in a higher torque level of the range of the tool, or is it better in a soft or in a hard joint for using in the production line. the mobile cell test, the configuration of is we have the possibility that we can build in here 4 simulators. And we have a lot of different simulators for built in this case. We have the possibility to have an industrial PC on it, or if customer decides they want to have maybe his own laptop, it's also a possibility. We have an external transducer connector or an external simulator connector. Maybe 500 Newton meter is not enough for your cases. Then you can connect bigger one simulators, and the mobile systems or mobile systems are including with an accu that you are independent of the main power working in the production line. And all the systems are prepared for calibration because it is necessary, maybe after 1 year, latest after 2 years, to make a recalibration of the simulator, and therefore the system are prepared. We have a lot of customer solutions, of course, in this case also on requested from customer. In this case, we have a handling system where we have an external simulator. You can see here the external simulator. You can move the external simulator. You can turn around. Therefore, you have the possibility to reach maybe a spindle which is built in, and you can connect this manipulator to the cell test mobile if you need. It is not needed that you use it every day, but if you need it, you can connect very easy and go with, including with the cell test and the handling system, to the production line and testing the spindles. And it is not necessary that you build out the spindles, and it's not necessary to interrupt your production line. Another customized cell test is a little bit bigger in the case, and there we have the possibility to build in 5 simulators, and 3 of these 5 simulators have the possibility to move between 0 and 90 degrees, and you can stop on each position where the position is that the spindle comes to this simulator. Or only if you have this in 90 degrees position, it is a little bit easier to test such hand tools in this position. You move the 3 simulators only by 1 button up and down. The stationary system is with 5 simulators here inside, and the biggest can be 1000 Newton meter. In this case, it is not necessary to have a special industrial PC. You have a standard PC here including, and a monitor, a touch monitor for easy using the system. It is also the possibility to have an external connector for bigger simulators. And also this system is prepared for calibration on site. We have a special mechanical device for fixing spindles. Here in this case, you see, to move this completely device on top of the simulator, which is used at the moment. And it is a very easy way to testing spindles, to fix the spindle on this mechanic and to test it. For bigger simulators, we have up to 2000 Newton meter, this chair, and it looks like a chair. It is up to 2000 Newton meter simulator, and here you can also fix your spindles and make an easy test with such another system. And For bigger simulators, we have the stolen, where you have the possibility to build in simulators up to 6,000 Newton meter. In this case, without the spindle holders. For click wrenches and display wrenches, you need another hardware. You need the Kali test. It's also the possibility to have it stationary or mobile. It is necessary to increase the torque automatically because the rule, the ISO standard 6789, describes this way of calibration, and it is necessary that you reach a speed from 80% of the value you want to test up to 100% of the value. You need a special time. You have to reach a time window, and if you do this manual, it is very difficult to reach all these requirements. Therefore, we have the automatic system. It is the Kali test, and mostly we have the stationary system, but also the possibility of a mobile one. And in this case, you see our Kali test with two drive units. We have a controller unit, and this controller unit is able to work with two drive units. In this case, we have a drive unit 50 Newton meter, and the range of this drive units, all drive units at the Kali test, going from 1% up to 100% of the value. In this case, 0.5 Newton meter up to 50, and the biggest one is 1,500 Newton meter, and it's the range from 15 up to 500 Newton meter. The mobile one, the biggest, is about 1,000 Newton meter, and also in this case we have two different drive units, 50 and 1,000. For nut runner and pulse tools, we have our cell test. For display wrenches and click wrenches, we have our Kali test. And now, Roberto talked about it, we have also, for both technologies, our combi test. The combi test is with a drive unit, automatic drive unit for calibrate wrenches in the standard up to 300 Newton meter, and in a special solution up to 500 Newton meter. And you have also the possibility to build in here 4 simulators for simulate the fastening point characteristic to testing nut runners. You see it here, the drive unit of the Kali test, the reaction bar, and you have to realize that the tool is in a horizontal position, and then you get the information. You can push the start button, and the system makes this calibration automatically. And in front of this, you see the 4 built-in simulators for testing the nut runners. In this case, also we have the possibility to build in 4 simulators, the industrial PC or the laptop support, external connectors, 24-volt accu for moving in the production line and working without the main power. And in this case, the standard is up to 300 Newton meter for the automatic drive unit to calibrate the wrenches. And Roberto showed also other torque wrenches, display wrenches. This is torque and angle wrenches. And therefore, if you want to test the angle, you have to move the tool. And therefore, we developed the cell test W. And in this case, you see an arm where you can put in the wrench, and for testing this, you have to brings the system in a start position, and after then the system moves this arm because the torque and angle wrenches, there are a gyroscope inside to measure the angle, and this gyroscope is only working if you move the arm. Therefore, we have this arm, and we move this arm, and the torque and angle wrench can measure the torque and also the angle. This we have in two different standards. In mobile one, 300 Newton meter or 500 Newton meter, and in a stationary system, it's going up to 800 Newton meter possibility. So all of these systems are working also within software. The software named SOIS. SOIS is, you can see the word, Central Evaluation Unit of Different Systems. You see, or you saw our CERTES system, you saw our CADI test system, and also the combi test, and Roberto informed about our mobile measuring systems, torque and angle wrenches, or small mobile measuring equipment, Inspect Pro. And all this measuring results are collected in one database inside of the SOIS software. And also a logo we have, that is our SOIS logo. So, different system. It's based on an Oracle database, and it could be a single place that you have only a CERTES with this SOIS software, or you have a CADI test. And the mobile equipment, Inspect Pro, and torque and angle wrench, or maybe you have also an office PC, and therefore you need a server system, a network. That could be that all the results of all this hardware are coming together in one database on one server, and you have in this case the hardware, but here also the possibility only with an office PC you can check what the results are. You can print out a lot of things. You can prepare new tests in the office PC, and all this information are on one database with one server. We have to prepare a little bit in front of using, of course, the tolerance classes you have to define, or a statistic parameter, how often you want to measure this point, or you want to have special requirements and CMK levels. And therefore, we have to prepare a little bit, and after then, we can use this prepared information. Very important part in this software is the user rights. That means every user has its own login and with its own password, and it is saved in the database who makes these tests, and different of the user groups are different rights to using the software. Of course, the next is the organization structure. You can build up your own company structure for tools or for the fastening points inside of this software. The measuring page, every time the same picture. You see the results from the measuring, and you see the value you want to have, the value you have, and also the CMK level you get the information about. After that, of course, sometimes you have to print out a certificate, sometimes only you have to show. It is different, and the layout of this certificate you can create by yourself, and also all the information you want to have, all the information from the database you can bring in this layout. The evaluation afterwards of the test, you can see what's happening in the past with all my results, what are the levels and the values, and also you can show graphs if you saved it during the measuring, and you can see in the what happens in the past with my results. And then we have a test scheduler that is the possibility that you can say, okay, I want to test this tool maybe every day or every week, depends on the fastening point where the tool is working. And there you can see at what time we have the next test, and you can see the results of the test in the past. In this case, it is an EO measuring result. In other case, you have a red one, it is a not EO. Okay, result. Yes, that was a short overview about some tool testing systems and our necessary software for using it, and the question and the answer part maybe we have after the last presentation from Christian. And I say thank you for your attention, and I give it back.
Thank you, Carsten, and thank you, Christoph, for your commitment on timing, first of all, thanks. Avete visto quindi la parte relativa ai componenti, la parte relativa agli strumenti. Vi ringrazio perché vedo che ci sono già delle domande e anche delle richieste di appuntamento dei clienti, quindi verranno esaudite sicuramente. Adesso passiamo all'ultima parte del collega Christian Stolmeier, che vi presenterà i nostri sistemi di verifica della qualità durante i processi di avvitatura. Christian, I leave to you the audience.
Okay, we can see your screen, but not the presentation. Christian, we can see your screen, but not the presentation.
Just a second, please.
Bene, avete visto comunque che abbiamo diversi prodotti in diversi ambiti e sicuramente una cosa che caratterizza Kistler è l'esperienza a supporto dei prodotti che state vedendo. I nostri product manager che sono intervenuti solitamente adesso, a parte il periodo, vengono anche in Italia e supportano i clienti con visite, con consulenza, con richieste customizzate. Quindi considerate che spesso, come diceva il collega Christoph nel primo intervento, customizziamo le soluzioni su richiesta dei clienti. Questo sicuramente è un aspetto molto molto importante. Ok, vedo che la presentazione è pronta. Christian, for you.
Okay, thank you very much, and also sorry for this little interruption from my side. We will take a look to the third field of our applications in fastening technology from Kistler. My name is Christian Stollmeier, and I am sales supporter in the team of Carsten, who did the presentation about tool testing and calibration before. And yeah, I have the pleasure to present now our process inspection instruments to you. First of all, I would like to introduce you the systems that we can offer. Afterwards, we will speak a little bit about the use cases and the general necessity. Corresponding on that, we have to use some different testing methods that we can offer by this system. And at the end, we also speak about connectivity to various softwares and some extended fields of application that we can also do with the Inspect Pro. So The Inspect Pro, you probably heard it a few times already during the session today. This one is our mobile measuring device. Yeah, that you can carry around with you with a belt, for example. It is battery driven. It has a foldable housing, and you can connect it to several sensors with strain gauge technology. The sensors could be active or passive, and yeah, it is a really nice to use portable system with a touchscreen, and it has a very intuitive user interface that makes it really easy to work with it all over the day. Yeah, it can be parameterized by the PC. You could also do backups, software updates, and software upgrades on it with the PC on your own. So it is not necessary to do a shipment back to us, to our plant. So you can handle a lot of things directly by yourself. We have several possibilities what we can connect to this device. For passive strain gauge sensors, we have 2 sensor connections, which allows to connect torque and angle of rotation sensor, for example, but also force sensor. Then we have also the possibility to connect active sensors with probably needed corresponding resistances. We have the possibility to use the RS-232 data output directly after each measurement. So yeah, you can monitor data at the computer. Connection for parameterization and software updates, backups, and so on will be done via the mini USB port. Right next to it, we also have the possibility to connect a mouse or a keyboard, or also a barcode scanner, which is quite helpful when using the device somewhere in your plant. There's one connection for Ethernet. It would be possible to connect an external monitor or to mirror the screen of the Inspect Pro to your computer. And last but not least, there's a plug for mains connection, to run it besides the battery. This one is the first part of our applications that we can offer you for process inspection. On the other hand, we have a device which is called the inspector. It is a torque and angle wrench. You probably already heard this before when talking about the ZSW. So this one is a wrench that measures the torque and the angle of rotation, and it's quite versatile too. You have also the possibility to connect a second sensor for force, for example. You can rotate the lever arm in steps of 60 degrees, which probably makes it easier to read the screen in different fields of usage. It has an interface to Zeus and Test Expert as well. We heard about this software already from Christoph and Carsten. It has a touchscreen too. We have in general a really robust housing, and what in my opinion is a really nice thing on this wrench, this indicating ring over here it will show us a step of tightening, yeah, depending on the way to the target. So when we hit the target, the LEDs will flash in different colors, and also the hand grip has a vibration. So this is a nice wrench, our inspector. And yeah, now we come to the general use case and the necessity of process inspection. So when we get an overview about the applications that we learned today, there was on the one hand the applications for fastener analysis, where we take a look to the bolts and its characteristics. After that, we took a look to the tools that we need to assemble the bolts and what we can deliver to test and calibrate these tools. And now we take a look to the process inspection. That means that both of the former parts are now included in the process inspection. So after the bolt was assembled with the tool in the production line, we come and we do process inspection tests on these bolted joints in the assembly line. And yeah, the target of this inspection would be to have a test which is okay. In case it is not okay, we get some points we can point out and go back to the things where we maybe need to take a look. This could be the tool, whether to check it, or maybe the setting is not correct. So this could be an indicator to take a closer look to the tool, but also to the bolt itself. So yeah, this is what process inspection in general means. We take a look to the bolted joint, and yeah, of course we do not want to have not okay results, but if we get, we can go back a few steps back. And also here we can monitor our parameters in a statistical way. So we have statistic process control on board, in order to ensure that all the measured results are saved. And just imagine an automotive OEM needs to start a recall campaign due to wrong fastened car doors, or let's say braking systems. That would be even worse. On the one hand, this would be a safety relevant joint with danger for life and limb. And on the other hand, this would be an expensive issue, and I guess nobody wants to be part of the tier supply chain in that case. So especially for this reason, it is necessary to monitor and to inspect the fastening processes. So we have seen now the Inspect Pro and our inspector. And what we do is inspection, or you could also say the validation of the fastening process. Generally, we can use it in two different ways. First one would be directly while the assembly. This is so-called in-process measurement. And we could also do this test afterwards. This can be done in the carry-on tightening test methods. We have the data acquisition and the savement to prove or improve the quality of our bolted joints. We do fulfill the tests according to the YDI standards. We have the SPC on board and also the connectivity and compatibility to SOIS. So yeah, we heard a lot about SOIS now, and in fact, this is a very comprehensive software for fastening technology, but it has nothing in common with the Greek god. And yeah, when we take a look to SOIS or the inspector or also the Inspect Pro, we can do several testing methods for process inspection. I already told a few seconds before the first possibility would be the in-process measurement, which means we connect a sensor for torque and rotation angle directly between the tool and the bolt to be, or the joint to be fastened. And on the other way, we have the possibility to use such a wrench, our analyze wrench, to use carry-on tightening procedures and test methods according to the YDI 2645 part 3. And yeah, generally these analyze wrenches do also measure the torque and rotation angle, but in this case we also use a gyroscope for rotation angle, and especially for process inspection, the handling in a wrench is way more comfortable. So when we dive a little bit deeper into these test methods, the YDI standard gives us a few solutions and a few procedures that we can use. The first one is just tighten the bolted joint a little bit more, and the maximum value will be displayed as the result. So for each of these results, you could enter a tolerance class on the Inspect Pro on its own, but also in combination with SOIS. That's the first test method we could use from the YDI standard. We come to the second, where we tighten to a predefined angle of rotation. For example, just 2 or 3 degrees more after the bolted joint was done. And at this angle of rotation, the torque will be displayed. So in the best case, we will not get the result over here. We want to get the result more here after the breakaway, and therefore the YDI offers some more opportunities. For example, to monitor and to look for the minimum torque in a window between 2 angles of rotation. So we tell the system this first and the second angle of rotation, and we will see and we will get the result directly, which is the minimum torque in this angle window. And yeah, this is a very nice functionality. And yeah, sometimes I wish I could even use it to monitor Bitcoin curses or some other on the stock market. But yeah, unfortunately, we cannot look into the future, so this will not work over here. But for fastening technology, it is a great possibility. The fourth part, named by the YDI, is the determination of intersection point. So when we go along the tightening curve over here, we have a steep a very steep rise of the torque. And after we get the breakaway, the angle will move further forward. And yeah, along these two lines over here, and then the more steeper one, there will be a straight line calculated, and the point of intersection is the residual torque for the breakaway, so to say. And could also look like this, because the torque can fall a little bit after breakaway, but this is also a quite nice way to come very close to this breakaway point. And then we have the last one that also comes from the YDI standard. This is a change of gradient. And here we do, let's say something similar. We take a look to our graph again, but this time downwards. And the system will recognize when the gradient changes in a percentage that we can define as a separate parameter. So when we now take a look to our inspector wrench, we also have some more possibility because we have a yield point procedure where we can take a look to the tightening curve and determine the point, the yield point, so to say. We can do that with the Inspect Pro as well. We have another procedure which would be releasing and tightening again to see how does it behave when it was fastened for the first time, and probably the bolter joint wants to be used another time, and of course we want to know if this is okay also after the second use. So this is the procedure for this use case. And also in order to look at the time a little bit, I need to hurry, I guess. We take a look to the connectivity and extended fields of application. You saw this already before by Roberto. So this is our Inspect Pro, where we can connect several sensors, for example, a rotary sensor for torque and rotation angle, but also a stationary sensor which does not rotate, only for torque. We have our analyze wrenches for the carry-on tightening test procedures, and also standalone force sensors, for example. With this combination of sensors and the measuring box, or the Inspect Pro itself, we can do several testing methods, these extended fields of applications. For example, tool testing to indicate if a click wrench is working properly, for example, or we could also do a small coefficient of friction measurement, but it is the smaller one, so to say. And we use optional software modules for that, and also some optional hardware stuff. For the European Union, we have the possibility to use the wireless analyze wrenches also, and to summarize this a little bit, for all these extended fields of applications, we have some special software modules that could be activated easily by yourself, and you can use them from then on. So we had the part of process inspection with in-process measurement and carry-on tightening. We have a little friction analysis, but for total friction only, And we can also do some tool testing, for example, with such a hand crank handle over here, with the static sensor in this case, for example. We can do the carry-on tightening test procedures together with Zeus. We can also do the tool testing together with Zeus for click wrenches, displaying wrenches or nut runners, for example. We can do the small determination and also evaluation for coefficient of friction on the Inspect Pro itself, but also in combination with Test Expert. And yeah, we can also do this with our inspector wrench. We have the possibility to work around these routes along the assembly line. The route mean we have a task of measurements that we need to do, will be parameterized by Zeus, done with the inspector or the Inspect Pro, and afterwards transferred back to Zeus for evaluation. And also with the inspector wrench, we have the possibility to connect a small load cell in order to do a coefficient of friction measurement. That was my part. Sorry for the little rush at the end, but yeah, I guess this 1 minute I went over is okay.
Yeah,
Thank you
it's
very much
okay.
again.
Thank you.
Thank you, Christian. It's 1 minute also in Italy. It's perfect on time. Don't worry.
Perfectly.
That's good.
Oh, okay, I'm gonna read the questions, and we received many questions actually. There is a question for each one of you. Ok, vi ringraziamo per l'attenzione dimostrata finora. Cercheremo di rispondere alle molte domande che abbiamo ricevuto. Nel caso non riusciamo a rispondere alla domanda che avete inviato personalmente, un nostro tecnico commerciale vi contatterà nei prossimi giorni. Allora, la prima domanda è per l'ingegner Marazza. Chiedono se il service, cioè l'assistenza tecnica, possa essere effettuato solo dalla casa madre o anche localmente.
Perfetto, grazie per la domanda innanzitutto perché mi permette di approfondire un tema importante a cui ci teniamo molto sia a livello di casa madre sia a livello di Italia o di paesi in cui abbiamo le nostre sedi. Quello che forniamo ovviamente è il supporto sia dalla casa madre, sì, ma in Italia siamo attrezzati per dare supporto diretto, quindi abbiamo tecnici specializzati che possono visitare i clienti facendo installazioni, dando consulenza e supportando appunto sul commissioning dei nostri strumenti, con anche in alcuni casi, a seconda dei prodotti, fare anche dei test. Dove non è possibile fare dei test direttamente da noi come filiale tecnica commerciale italiana, ci possiamo appoggiare alla casa madre e quindi fare anche dei test in casa madre, ma il supporto comunque in Italia è presente localmente.
Ok, perfetto. Un'altra domanda che abbiamo ricevuto. Christoph, this question I think it's addressed to you. Is the software limited to fixed test procedures when the system will be installed? How about flexibility?
Yeah, that's a very good question. The point is with our test expert software, we have a really big possibility to create really the requests of you as a customer. So during the installation, we make a basic training for the participants. So our software is using a so-called block structure. So we have different blocks, and we put these blocks together in the direction we need. So we will make this training on site together with the customers. So after the training, where we installed the basics, the customer has the possibility to use the knowledge we transferred during the training and create the procedures by himself. So he has the flexibility to make things whatever he wants. So even if he make a fastening, go back and loosen, and then he make a second fastening to a defined angle or to a defined torque or clamping force or yield point or whatever. So he can make this combination by himself.
Ok, thank you very much. Ricordo a chi si è connesso più tardi che le domande si possono scrivere nella casella in basso a destra sui vostri schermi. Cercheremo di rispondere o in questa sezione o nei prossimi giorni. Ok, another question, I guess it's for Christian. How do I decide whether I want to perform an in-process measurement or carry on a Titan measurement on the Inspect Pro?
Yeah, that's a quite good question as well. So basically, this depends on the fastening process itself and yeah, the field that you want to and the results that you want to get. The in-process measurement will, yeah, let's say, monitor your fastening process directly with the original parts. The carry-on tightening test procedures are supposed to work after the original assembly. For example, a first time directly after it, maybe a second time after 2 hours, maybe a third time before it, and probably a fifth time in the next day, to keep and to get a feeling about setting behavior in the assembled joint. And yeah, depending on that, it is to decide whether to monitor the process itself or to monitor the process afterwards.
Okay, thank you all for participating and stay connected so far to the audience. I thank you. I know that we are 15 mates, so I am going to ask the last questions to my colleague Karsten. Is the third test system able to calibrate not runner or only test possibility?
Our third test is,
Yes.
you hear me? Our third test is able to test the nut runners because there are no rules. There are no calibration rules for calibrate nut runners. The calibration rule only existing for calibrate wrenches. And for nut runner, they are only available and testing rules as the VDI 2645 page 2 or the ISO standard 5393.
Ok, thank you very much. Lascio la parola all'ingegner Marazza per la conclusione dell'evento.
Grazie Valentina. Ringrazio nuovamente Adere, Christoph, Karsten e Christian per il loro supporto. Ringrazio tutti i partecipanti, siete stati veramente numerosi e soprattutto tutti hanno atteso la fine dell'evento, quindi siete stati veramente molto gentili. Vi invito ancora a scrivere le domande, ce ne sono state molte, quindi vedremo di rispondere poi separatamente a tutti, di contattarvi, comunque non lasciare nessuna richiesta nel vuoto. Vi invito anche a suggerirci eventualmente degli sviluppi, delle vostre necessità. Kistler ogni anno investe molto del fatturato in ricerca e sviluppo e questo lo fa grazie ai clienti con cui collabora. Per cui sì, rimaniamo in attesa delle vostre richieste, di un vostro contatto e vi ringraziamo ancora per aver partecipato a questo seminario. Grazie mille e buon lavoro a tutti.
Thank you all very much for your participation.
Thanks a lot for your time.
Thank you very much.
Bye bye.
Bye, bye.
Bye bye.
Bye bye.